Hey everyone, Radhe Radhe. My name is Ayan Pasha. I'm the CloudNative advocate. Today we'll be continuing our Kubernetes playlist. Sorry for the huge delay in the videos. From now, I'll be uploading at least one video on every weekend, maybe on Saturday or Sunday. So today we'll be learning about some of the basic, components of the Kubernetes or the cloud-native landscape or the whole Kubernetes landscape to be it. So today we'll be learning about the some of the base components on which the whole system or the whole architecture of Kubernetes usually relies upon. So today we'll be learning about the pods, replica sets, deployments, and its various containers and managing policies as well. So and also we'll be getting our hands dirty with the lab work as well. Seeing out of the lab how do we create all these particular containers as well, or the pods or the namespace deployments, replica sets, what are the uses of all of these particular things. So yeah, let's get started. So coming back to the pods, so pod usually forms the most pods are the smallest or the most atomic components of our Kubernetes cluster. It usually contains various different kind of the containers. It usually contains different containers and the images, which are the our applications instances, which could be the front end, back end, various components of the front end as well. Different kind of the HTML files or the CSS files and all these particular things, which usually builds up our whole application layer. It could be also our database layer or the security layer and various different things as well. So pod usually contains different containers. It can hold one or more than one container, and pods usually have one-to-one relation with the containers. So it's also it is much more ideal if we will hold only one container in one pod, because if we hold more than one container in our pod, then all of those particular containers will be having an internal kind of a relation within the pod as well. Like they will be sharing the same namespace, they'll be sharing the same storage as well, they'll be sharing the same networking policy that has been laid for that particular pod. Also, if we usually in future holds up any particular kind of the replica rules as well, like create 3 to 4 replicas, or if our pod usually get destroyed or created or replicated, then those particular containers that are running in our pod, they'll also get destroyed or either created in the new one as well, even if we doesn't need that particular container at the moment. Like if we have a lot more space with our application, we doesn't need any more space to be provided to us. We have a lot lesser number of users, so we don't need another server that's to be run in our container. So in that way, we should have a single container within a pod, instead of uh, getting all of them packed within one pod. So it won't be much comfortable when our application will grow, when our user base will grow, and in the future scaling problems will usually takes place. So that's about the pods. uh, Next one is the replica sets. Replica sets usually helps in creating, in replicating our pod whichever we have created. Let's say in future, like at the moment, if we have lesser users at the moment, then we can rely on to one particular pod, but in the future if we have more user base, then we will have to replicate our pod as well, so that it will be handling a lot more requests that are coming at the moment. And then later on we can also apply different network policies or to different pods at the moment. Although if we will replicate them, then the networking policies might also get replicated at the moment. So yeah, it's kind of a basic thing. So that's about the replica sets as well. And in pods, we usually you know uh, whenever we have run to create any particular container image, then the kubectl command usually runs a particular container or the image, and then automatically deploys it along with the pod as well. So if we run like the kubectl run nginx image nginx, so with the image tag dash image, it will specify about the path of our image that is present at the moment in the public or private repository, or the place where it is being stored at the moment. So it will be deploying and binding our container along with a separate pod, and then deploying it automatically with the kubectl command. We'll be discussing about the kubectl command, kubelet, kubeadm, and various other things, and package manager things as well. Package manager, tools and services as well in the next lectures. So it was all about the replica sets and the pods. Earlier we used to have a replication controller as well, where we know. Alright, so the controllers are the brain of our cluster. Different controllers usually controls different things. Replication controller is also one of the controller that usually handles about the replicas that are running at the moment in our cluster. Whatever amount of replicas we have created at the moment, a replication controller will be taking care that the um, number of replica that we have set in our definition file, those many number of replicas of the pods are being running at the moment in our cluster, so that adequate amount of traffic handling would be managed properly at the moment. So replication controllers are helpful in controlling the number of replicas that are running at the moment in our cluster. Uh, it was handled earlier. It also used to have the API version v1 instead of having the apps slash v1 for managing the different apps in our like the all the apps in our Kubernetes file. So the API version usually acts as the rule book for our uh, YAML manifest file or the definition file, whichever we have been writing for. Think about it as in the Python, Golang, or any other language as well. We usually import libraries as at first, so these are also kind of those also work as a rule book or the predefined functions that are written in those particular files. So in the same way, API versions, whether it's about the V1 are the most core API handling library or the rule book. About the apps V1, it will act for the all the apps for handling all the apps app related API versions in our Kubernetes cluster, Kubernetes architecture. And then we also have later on you will also get to know about the networking dot kubernetes.io slash v1. They'll handle about all the networking policies that we handle in our Kubernetes architecture, application architecture. So yeah, that was all about the pods, replica controllers, and the replication controllers as well. So yeah, all right. And the next one is deployments. Deployments usually acts as a manager, which will be helpful in managing all the replica sets as well. Replica sets usually contains all the or your original pod as well. It holds the whole set of replicas along with the original pods. So the replication pod you can consider in like as an analogy, replica set could be your hiring manager, which will be taking care of all the employees that are required to work at a particular site. So if any particular employee leaves at the moment, or you need more employees, then the hiring manager will be helpful in hiring more uh, employees for your application, for your whatever project you've been working for. And the deployment usually acts as the project manager, which will also take care of the hiring manager as well. So any rolling updates that are being done, any behavior that has to be told about, that what kind of employees you need to hire, all of those information are being given by the project manager. So any rolling updates or any security updates or any behavior that has to be took care of, those are done with the help of the deployments. And that's why it's more recommended to build up our replica sets as well from the deployment file, like defining our replica sets as well from the deployment file instead of separately defining them all, because it will be a lot more troublesome in finding out the doing the troubleshooting part as well of your application. If you find any particular kind of bug, then it would be a lot more difficult for you as well, if you have lesser chances of getting uh, bugs in your replica set. So it would be a lot more comfortable in defining your replica sets as well in your deployments, and then later you can troubleshoot and find what's the bug. Right, so that was all about the deployments, replica sets, replication control, and pods. Now we'll be focusing about the lab part. Yeah. So let's try to get our hands dirty with the lab work. So let's get to uh, run some of the pods, and let's create some of the pods along with the containers in our cluster at the moment. So I have some of the pods that are running in my cluster. Sorry for that. Alright, so I am having some of the pods which are deployed in different deployments or also in the different namespaces. We'll be covering about the topic of namespace later in the next lecture, as well as also we'll be focusing about the services and various other things as well, which are more, inclined towards the networking layer of our application. So here we have all the pods. To create a particular, pod, we can run this particular file, this particular command. You know. And then the image tag usually tells the path where our cluster, where our container, or the image is, where our image is present at the moment. So, yeah, a new pod is created. If we will run the earlier command, then we can see our Nginx one. If we want to, dive deeper and have a lot more described, details about any particular pod that we have created at the moment, then we can run the describe command by specifying the same pod that its name has all the details about our pod that we have created just now. Its name, namespace, priority, service accounts, nodes. We ran a container as well. Yeah, the image. We specify about one particular image as well. It's pending. It is at a pending state because it hasn't been, given any. It hasn't been linked to any particular node at the moment. It's in the pending state. That's why if we will link it to any particular node at the moment, then we will get we will get it running. And then also let's try to look into the some of the files that we wrote earlier. Pod definition file. Let's try to know how to define a pod definition file. Although we have created one pod with the help of just one command, but it isn't, as you can see, most of the things haven't been set at the moment. So you can't define much things in the, in just one command. So that's why let's try to view what has been written in our pod definition file. So So as you can see, its API version is V1, has been set to V1. It's the core API version library. And then the kind is pod. Have you usually mentioned about the, the kind that we have been creating at the moment in our YAML manifest file. Then comes the metadata, where we try to, explain about the pod or explain about the resource that we've been producing at the moment. So its name, we have named it my pod, my app pod. And then the labels. Labels are like all of these metadata, the things that we have mentioned, these are considered as a kind of a dictionary. We have been setting up them as a kind of a dictionary. And then in the label section, we are setting up some kind of labels so that it can get referred by some other, some other file. Like for example, we have also defined our replica sets as well. In replica sets, we usually refer to them with the help of the labels that we have mentioned of our, pod. So yeah, we have the labels. App is my app. Type is front end. You can also set up the backend database or any custom-based type that you might have created in your application at the moment. Then comes the spec of the containers for our pods. Containers name. Okay, so here in the containers, we might have one or more than one container. So that's why it's been defined as a kind of a, a kind of a list or the arrays. So that's why we have just made named name as Nginx container and the image is Nginx. Name is Nginx container. We have been referring to the, the name that we have given to that particular container. Otherwise, the image that is using that the Docker Hub registry that's holding it, that name of the image is Nginx. So that's about the definition file of our pod definition file. So we have deployed it as we can see in our pods. It's running at the moment. My pod, here it is, and then some other replications as well that I created earlier. So let's try to look into the sorry for that. Let's try to look into the definition files of some other things as well. I have also defined about the replication controllers as well, but it is now not
and use as much. So that's why we won't be discussing about the replication controllers. We might discuss about them in the later sections. Let's for now try to look into the replication controller, the replica set. So replica set definition file. So here the replica, the API version it's using is apps/v1. It is helpful in managing the apps apps APIs of our Kubernetes. And then the kind is replica set. Metadata is name thing from which it will be, referred to at the earlier stage. My app replica sets. And then the labels, my app front end, same as as our pod because we are just replicating our pods. That's why we'll be naming the same, we will try to name it same. Otherwise, we can opt for some other things as well, so for some other labels as well. In the spec function, we will be specifying about the replicas that we want to create of that particular pod that we'll be referring in short, and then the selectors. All right. So in the selectors, we usually define about the all the metadata in the below section that was being mentioned in the pod section. We'll be mentioning about the pod that we'll be replicating. All right. So in the selectors, we have replicated or mention about the same match labels, selectors, match labels. Type is front end, same as our pod, you can see. And then comes the template metadata. Metadata is also same as of our original pod. You can see metadata, name, labels, my app pod, my app front end. Same goes for here. And then the spec and containers, they can vary according to us, whatever we want. As in the earlier stage, in our pod definition file, it was nginx container. And also we try to name the same nginx container because we are replicating the same pod, so that's why the same contains and replica sets would be replication would be done on the same container. So that's why we will try to put the same labels as well, same labels, containers, and all those that are mentioned in our pod definition file or the original pod definition file. So that's why we have mentioned the same whole thing in the spec function after the match labels, template, metadata, spec, containers, all of it are same as the as our pod that we are trying to replicate at the moment. And then if we try to look into the replica sets that are running at the moment, kubectl get replica sets. Yeah, you can see. My app replica sets, it's a different deployment. It's a different replica sets. As I said, this particular replica set, I have mentioned it because we are having two replica sets at the moment. One is three, as we all right, so one more thing. I have we are having three desired and the current as three replica sets, but here we have mentioned four replicas because I have changed the number of replica sets from a single command as well. We can change our replica sets that we have mentioned, but it's not recommended. As you can see, I have four replicas that are mentioned at the moment in our definition file, but since I ran a command earlier, which requested to run three replicas at the moment, so that's why it's running only three replicas. So in the later stage, when our application might grow and have a lot more user base, at that moment, if we find some kind of troubleshooting or we have any kind of problem or bug in our application, that we it would be a lot more difficult for us because it is showing that we have to run, we should be running four replicas at the moment, but we are only having desired three and current, and no problem can be seen at the moment. So it would be a lot more difficult for the developers and the engineers at the later stage to find what's the problem in our application. So it's it's recommended to edit our original definition file, and then since the Kubernetes is immutable, so that's why all the changes that would be pushed, it won't be pushed to the editable file. It won't be like just edited. It will first delete the earlier or the previous image that we have created, and then a new image of the edited definition file will be pushed to our application, to our cluster at the moment. So it's kind of a snapshot of our image or the definitions that we have created at the moment. So yeah, and the whole new resource will be created, and then it will be deployed to our cluster. So as we can see, my app deployment, if we want to know more about this particular thing, so we can just kubectl, wait a second, kubectl describe. Oh, happy was that? Yeah. So here we can see it has a lot more definition, a lot detailed, breakdown of our replica set at the moment. Name is this namespace default. We usually have three namespace at default. We'll be covering about it in the next lecture. Then the selectors, I mentioned about the selectors in the our file. They are selectors, match labels, front end, and selectors for YAML type is front end, as we said earlier. Then we have the labels of the pod that we are running at the moment. So then the app is my app, pod template hash, that's the hash code, hash value. You might have heard about it, you might have learned about it in your, DSA, data structure algorithm. So here's one of the application of DSA. If you would ask me what's the use of DSA in our course, why we are running, learning about them all. So, and then the type is front end annotations, different annotations. Yeah, these all are some really interesting things that we'll be breaking down in the future lectures. Right, so it is it's the replica set, and then let's try to understand about the deployments as well. So we have, yeah, it is deployment file of. So let's try to look into the deployment file. Yeah. So here is using the same API version as our replica sets. That is the apps/v1, and the kind is deployment. Metadata is my app deployment. We have named our deployment as my app deployment, and then the labels are my app and front end. Specs. Look, here we have mentioned our replicas as three. So for the earlier explanation, over here we were having only one replica, so I might have changed replicas to only one earlier. Here we have the replicas as term to three. Here it will be having different replicas um, that are mentioned in our deployment file. Then comes the selectors, match labels, same as our pods. Then the template comes with the metadata and the spec that belongs to the original pod that we might have created earlier stage. Name is app pod, my app pod. Then the labels, my app. Type is front end. Nginx container. Nginx same as our pod, original pod that we created earlier. Here it is. Look, same. Uh, yeah, over here as well. So that was all about the deployments as well. These deployments are really helpful in rolling updates to our cluster. We might have changed, like we want our cluster or our pods to behave in other certain kind of a way. So that's why we can specify about all those particular behaviors in this format, and then push all those particular sets. Also, our Kubernetes is kind of an immutable structure, usually adopted an immutable kind of a structure and approach. But in the later or in the previous version of Kubernetes, we have also witnessed that we have a resizing capability of pods as well. So there we can resize our pod so that we can manage the stateful apps that might be running that has to be continuous, and so all those particular features are also helpful. Uh, Deployments also help in rolling updates and keeping the stateful apps up and running instead of splitting them up and slowing them. It could be a really tedious kind of a work from the engineer's perspective. So here we have discussed about deployments, about the pods, replication controller, replica sets as well, and the computer quota will usually you will get to know about in the namespace of the so yeah. So that was all about the Kubernetes, about the basic features, about the basic layers of our Kubernetes architecture at the moment. In the next lecture, we'll be discussing about the services. It's a really important and interesting thing. We'll get to know about the services, node ports, cluster API, and the global API and external API, external IP. It is a lot more interesting thing. We'll get to know about the namespaces as well, what kind of namespaces we have by default in our cluster, and how we can create more namespaces as well, and how it can help us in deploying a lot better application for our use. So yeah, that was all about the today's lecture. Thanks. Radhe Radhe.